In this video, we want to talk about extending that first quadrant through the rest, because a lot of times, even with that hand trick, I'll have students say, okay, well now I know how to do that first quadrant, but that doesn't help me at all past that. I only know 0 through pi over 2. Well, the thing you have to remember is that anytime you're going around the rest of the triangle, let's say you were using that pi over 4, that 45 triangle, if you want to know something about that this quadrant, there's another triangle right there. If you want to know something about this quadrant, there's another triangle right there, another triangle right there. Well, this is pi over 4, right here, and that's pi over 4. This is 3 pi over 4. Notice it's got the same side lengths. The only thing that might be different are positives and negatives. Down here, this is 5 pi over 4, same side length, same triangle, and this is 7 pi over 4. So all you should have to do is use the same numbers over and over again, just adjusting the positives and negatives. And that's where it becomes really important, again, to remember that. I'm going to write it right here, that x coordinates go with cosine, and that y coordinates go with sine. Okay? So anytime the x-coordinate would be negative, anytime over here, you know, on a Cartesian plane, these are negative x's on this side of the y-axis. Anytime that x would be negative, cosine would be negative. Anytime y would be negative, so down here, sine would be negative. And that's all you need to remember, because any multiple of a triangle, or if you're using the finger trick, any multiple of that angle over here will have the same absolute value. All we're going to need to do is change the sign. Now, you see I've written some things here. I've written pi over 2, 2 pi over 4, which would reduce to pi over 2, 3 pi over 6, which would reduce to pi over 2. Over here for pi, I wrote 2 pi over 2, 3 pi over 3, 4 pi over 4, 6 pi over 6. I'm not saying you need to do that every time. I did the same down here. But it does help sometimes to extend the triangle to know where things are. And I'll give you a couple examples. Like, let's say we wanted to know the cosine of, let's say 5 pi over 6. Now, for a moment, I just look at the denominator. I say, well, it's a pi over 6. A pi over 6 on my hand trick was this finger right here. Was that finger, you know, 0, pi over 6, pi over 4, pi over 3. It's this finger. I have 3 fingers above. Cosine was above. It was always square root number of fingers divided by 2. I know it's square root of 3 over 2. I just need to decide if it's positive or negative. I know that's its absolute value. So 5 pi over 6. Well, 3 pi over 6 is here. It's more than that. It's 5 pi over 6. 6 pi over 6 is here. It's got to be in this area. In fact, it's right about here. But it's got to be between 3 pi over 6 and 6 pi over 6. It's in the second quadrant where the x-coordinates are negative. So it's negative square root of 3 over 2. And all you need to use is the hand trick combined with what you know about where x and y are positive. Let's do another. Let's do the sine of 7 pi over 4. Now you're going to notice they're all multiples of ones we know. They're either going to be over 6, over 3, or over 4. You aren't going to be asked to do ones that you don't know. You're not going to be asked to do ones over 7 or over 12. Well, okay, so I would just ignore the 7 to take it some kind of pi over 4. So I go to my hand trick. Remember, 0, pi over 3, or I'm sorry, pi over 6, pi over 4. It's that middle finger. Sine was below, so it's the square root of 2 divided by 2. Square root of 2 divided by 2. And again, I just need to decide positive or negative. Well, here's 2 pi over 4. That's bigger than that. Here's 4 pi over 4. It's bigger than that. Here's 6 pi over 4. It's bigger than that. It's got to be in this last quadrant right in here, because of course this right here, if you're putting it over 4, this would be 8 pi over 4. Well, it's somewhere between there. Well, in the fourth quadrant, remember sine matches up with the y-coordinates. Sine is negative, so we just put a negative there. So sometimes when students have a real hard time knowing where things are, I tell them, build more. Don't just say it's pi. Remember, it's 2 pi over 2. It's 3 pi over 3. It's 4 pi over 4. That really helps to know where things fall. Okay, let's do another one. Let's do the cosine of 2 pi over 3. Okay, that one's a little bit trickier. Cosine of 2 pi over 3. Well, it's a pi over 3, so I'm going to start with this. Remember, 0, pi over 6, pi over 4, pi over 3. It's cosine, so it's number of fingers above. I only have one finger above, so it's going to be square root of 1 over 2. Okay. Now, cosine 2 pi over 3. You notice there isn't a pi over 3 multiple here, but here's 3 pi over 3. It's got to be somewhere right in here, okay? Because it's over pi over 2. It's 2/3. So over in the second quadrant, x's are negative, so it is negative 1/2. You can build the whole table. You can extend the whole thing really, really quickly using these ideas and knowing when you get over pi, when you get over 3 pi over 2 by just building that way. Now the one last one I should do, because we haven't done one yet, and I said we tangent built off of these other things. If I did the tangent of, let's do 7 pi over 6. Okay. Now remember from pre-calc that tangent is really just sine divided by cosine. The reason that works, of course, is tangent is opposite over adjacent, and in the unit circle we found that the sine was opposite over 1 and cosine was adjacent over 1, so that's why that works the way it does. But you see, we can build tangent using sine and cosine. So 7 pi over 6, again, let's focus right away on the fact that it's a pi over 6. It's some multiple of pi over 6, so I'm going to use that pi over 6 finger. We got to do sine first. Well, we don't have to, but sine's on top. So number of fingers, it's 1 finger. So it's going to be square root of 1 over 2. We've got 1/2. Okay, that's the sine of 7 pi over 4 is, or 7 pi over 6. That's the absolute value. Now, 6 pi over 6 is here. So 7 pi over 6 must be there, down in here. Those are negative y values. So I'm going to put a negative. Next, we're going to do the cosine. Well, the cosine of 7 pi over 6, again, we're using that pi over 6 finger, so we got 3 fingers above, so it's the square root of 3 over 2. And 7 pi over 6 we found was in this third quadrant where the x's are negative. That's going to be negative as well. So there's the sine of 7 pi over 6, there's the cosine of 7 pi over 6. And remember, dividing fractions, we just multiply by reciprocals. The negatives, of course, will cancel. The 2's will cancel, and we'll be left with 1 over the square root of 3, which you could rationalize to be square root of 3 over 3. So you see, you can build the tangent the same way using the hand trick and the unit circle.